and Asteroids from RDFZ China. Our mission is to build a sustainable space station which utilizes asteroid belt as a source of maintenance.
First of all, we need to find a location for our space settlement. There are two requirements for the orbit of the space settlement around the asteroid: distance and direction. In order to extract the materials to the maximum extent, we want to search for a main asteroid which is mostly made up by metallic elements, which is useful for us and can be transported back to Earth or somewhere else to create benefit for the space settlement. From the database of Paris Observatory's Small Object Database, we carefully selected the asteroid 420 Perseida as our center asteroid. Its orbital parameters are shown above. Asteroids, an area of virgin lands where no one had ever explored in scale, are in possession of quite many mineral resources, and a large amount of them is worth utilizing. The asteroid belt has multiple benefits on the transfer of passengers and cargo in the solar system. Additionally, it is also an ideal place for certain industries. And the planet Jupiter, the neighbor of our asteroid, can also provide a plentiful supply of the fusion fuel, hydrogen.
We use laser ring as the mining machine. The principle of the laser ring is by refining the plasma auxiliary gas in the magnetic field, and then direct the laser heated gas to cut the rock. Laser would drill a hole inside the areas worth exploring and keep detecting the element distribution inside the hole. As long as it is still worth mining, the drill would continue, and finally, the robot would separate the pieces of ore and carry it back in its container. We would be extracting the majority of economical valuable zones of one small asteroid at the expense of cutting it into two. The surface area of the asteroid will also be inspected and drilled.
Secondly, we have designed a structure with specific features that aim to ensure the safe, effective, and prosperous operations of the asteroids. Our station is built around a central axis 1.5 km long in total. 3 tori with different purposes form the peripheral structure. From the top to bottom, they are designed for residential, agricultural, and industrial activities respectively. For the need of gravity, the tori are set to rotate independently from the central axis structure, powered by 8 auxiliary propulsion Bessemer engines on the outer surface. Throughout the settlement, we take advantage of modularized structures during both the building process and in cases of contingency. Mechanical locks can effectively fix the modules that divide asteroids further into specified sections. Our central command bridge is located between the agricultural and residential tours, where it is also close to the geometric center of the station. Last but not least, there are backup storage and contingency sections that contain automation systems, backup energy, food, and life supporting systems. The spokes connecting the residential tours will remain stationary for better transportation experiences, while the industrial and agricultural ones will rotate to gain linearly distributed gravity. This enables multiple space industrial facilities and crop plantations, as well as scientific experiment environments. Another important link in our design involves the spoke axis transfers. Our approach is a structure called transition tracks, with one end being an annular spoke axis joint and the other fixed mechanical locks on the torus. The joint is a unique H-shaped structure that wedges into the outer surface of the central axis. We are able to keep the tracks superconducting for electromagnetic driving forces due to the low temperature in space. With gates at contact locations, we are able to maintain habitable atmosphere conditions in the manned areas. On the exterior surface, 4 symmetrically distributed transfer tracks and tiny docks are deployed for robust and very small ships. Two separate sets of transfer tracks on the top and inside axis are set to meet the demand of a higher transfer efficiency and different demands of transfer conditions at the same time. We use multiple thermal insulation materials and heat pipes to preserve heat. Electromagnetic shielding is used for radiation protection. The deployment stage will be completed with the assistance of auxiliary robots. They will assemble the station from an exploded wheel. And then the modules will be installed in a certain sequence. After initializing spins and ejecting air, asteroids will be ready for settlers, researchers, and visitors.
First of all, we divide transportation into two parts: exterior transportation and inner transportation. In exterior transportation, we design docking parts for spaceships of vast variety of shapes, from diameter of 10 meters up to 50 meters in length. In our design, the simple section of the spaceship is designed to have the shape of hexagonal prisms. In this form, hundreds of single units connected with each other and specialize in their roles. Some remain their original function of holding passengers, some fill with goods, and some serve as engine section. In this way, the spaceship will be able to meet the needs of transporting immediately and flexibly. This honeycomb shape of the smallest section will ensure the total strength of the structure, which comes to terms of complex form, which contains 100 or more small sections to travel for long journey. Benefits from the shape of hexagonal primes is the spaceship will have the ability to change and reconstruct at a variety of structure and components. For inner transportation, we have bullet trains, cargo lines, and community shared bike. Powered by the electromagnetic introduction gun, the speed of the train could reach 1 km per second. Every train contains 3 cabins, and each cabin holds 30 seats and plenty of seats for people to stand. This is a road module. Green represents the roads for sharing bike. Black areas are for residential facilities. Gray areas are the parks which serve as divider of two neighbor blocks and improve environmental quality. Blue cubes are the stations, and white and yellow lines is a row of cargo lines and bullet trains.
Then we designed our system of life support and our facilities for recreation. We tend to improve people's lives through biological technology. There are several technologies which we have utilized in our space station. For the last few months, we have spent every day brainstorming new designs. We dream big because we are pioneers.